Hello, in this video we'll determine the LINEST output of this data range. We'll calculate the slope, the intercept, standard error estimate, degrees of freedom of the denominator, residual sum of square. We will also calculate the slope using the COVAR and the variance. And we will also use the standard error estimate function to calculate the standard error estimate. We begin with the LINEST function. We have y, and data x, and show the full statistics. This time we'll calculate the slope, intercept, standard error estimate, degrees of freedom of the denominator, and the residual sum of squares. So we start with the slope. Slope is calculated using the slope function. Likewise, the intercept is also calculated using the intercept function. The slope can be calculated using covariance over variance. So let's start with the covariance of the population or the data set. And the variance of the data set. Variance of the population of the data set, or X. Now we divide. So this is equal to covariance divided by the variance. And we get the same result for the slope. Now that we have calculated the values of slope and intercept, we can now determine the y-hat value. This is equal to the intercept plus the slope times x. And as we copy this to the rest of the column, we lack the references. We lack the reference of the intercept. And the intercept, the reference of the slope. Now that we have locked the references, we can now drag or copy the formula to the rest of the column. So we have completed the y-hat column. We have the y-hat, the y column, and the y-hat, or estimated y values. Now we can calculate the residual sum of squares using the formula sum of the square of the difference of y and y-hat. Next, we calculate the degree of freedom. We can check our residual sum of squares matches to our LINEST output. We can also calculate the degrees of freedom, which is equal to rows of the data set minus the columns of the data set. So our degrees of freedom is 7, matches to our LINEST output. Next, we calculate the standard error of estimate, which is equal to the square root of the residual sum of square, or RSS, divided by the degrees of freedom of the denominator. So we have 1.12, which matches to our standard error, the LINEST output. And this can be calculated using the standard error functions, the STEYX function, data y and data x. This matches to our LINEST output and our calculations.